Okay, so this most likely would be the last video on this. This is the parent-child database change dive that I want to do. So uh, we have a few more public declares. These are all the standard ones that we've already seen. And we have a couple private declares. Okay, so private, that means you can't see it from when you type in work or sprite sheet : these two don't show up. The only ones that are going to show up are up here that are exposed to the world. So what I want to do is go through these down here, and we will take a look at, first we'll do load. So when you find a sprite sheet, what he does is load up the sprite sheet, and then he calls to load his children, and that's this function right here. So find's been tweaked. It has this another record added at the bottom that says, load SS tile collection, and here it passes the reference to the sprite sheet. So we have one database connection. So I have to be careful how I do this. So first we get the IDs from Sprite Tile that are referenced by our sprite sheet ID. So once I get those, I load them into a list. FID is just a list of integers. So we load up all of those, and then I close the database, and I'm done. That query's done with the database. And then I take and spin my FID collection, and we iterate from the first to the end. We add a row to SS tile, and then we do the find, passing in the ID to, this is a find on SS tile. We pass in the ID, and we pass in a reference to our collection object instance of SS tile that we just created. So that's how we load. It just calls the standard find. Likewise, on the save, when you save a sprite sheet, he needs to first, what he does, because sprite sheets, tiles are children of the sprite sheet. So the sprite sheet has to be saved first if it's new, because it doesn't have an ID yet. Once he gets his ID, then he's clear and good to load his, save his children, okay? Because children don't have the IDs until we get here either. So part of the save is when initially, if you actually delete a tile inside a sprite sheet, he doesn't really delete the tile. What he does is he moves him from the SS tile collection to the delete SS tile collection. And so it now no longer appears in lists and stuff like that, because the delete is never referenced there. The active tiles are only in the SS tile sheet. So when we save the sprite sheet, we spin the delete collection, and we call the delete method of SS tile and delete off all the ones you deleted. Then we come in, and this is where the value of a state comes in very handily, and you need to understand what I'm doing and how I'm doing it, or really why I'm doing it, the way I'm doing it. So we're going to iterate through the entire tile collection. We're going to select the record. We're going to make sure that the child collection sprite sheet ID equals our class of sprite sheet, his ID. So that way we guarantee they're linked. And then we take those that were marked as new, dirty, and put them back to being new. Once we have that, then we can say this little block here says if they're not new, I'm going to mark them all dirty. Okay, so 99 times out of 100, I've found that this is so fast. The pain in the butt it is to keep up with what is dirty, what has been changed, what are all the parent ramifications of that, is virtually null and void. It's over in less than a half second. So it doesn't matter whether you saved 1 record, 5 records, or 200 records. It's grease lightning. So that's the default of the system. When you save a parent, he saves all the children. Now, there are times when you will want to break that paradigm, and you will want to keep up with what changed and what is not changed. For instance, I wrote a program recently for building grids for games. And this program has such a massive database with it because he has a sprite sheet of the grid itself. Each hex in the grid has an image and its own class, and then that hex is made up of multiple images. So you can see that if you had a 25 by 25 grid of the game, each cell is its own class linked to the actual graphic layer, of which you can have many graphic layers. Then you have each of those cells broken into many individual images that are stacked. So real fast, the math multiplies to where we were saving 100,000 records. Well, that's slow. That may take a whole 30 to 60 seconds, and that's relatively cumbersome. So what I did on that particular piece of software is I kept up with all of that, what is actually really changed or not changed, commented this block of code out to where he only saved those records that the person modified. So it all of a sudden went from saving 20,000 records to saving just the 5 or 10 that were actually necessarily needing to change. So you have to look at your situation and what it is that you're doing with your code. Here is where it's controlled. So if you leave this block of code in, then everything's dirty. We come down here, everything will fall into it's new or it's dirty. If it's clean, we're going to ignore it, but nothing can be clean. So this is where that's controlled, and that's in the save of the child collection, which is a private procedure.